Hello everyone, good evening. So we're going to have physics. Now what I'm going to do is that last time when we had physics, I think the voices, the audio and the picture was not synchronized. I think that's what I noticed. I don't know what caused that, but the audio and the picture, or rather the video, were not synchronized, such that um, I'm saying this, but what I was doing, like what I was writing, was something else. So what I'm going to do is I'm going to just do a bit of a recap of what we did last time in physics, very quickly, and then we're going to do something else. Basically, it's just a continuation of what we are looking at last time, because remember last time we only looked at one example on the two types of addition and subtraction that we looked at. But we said that we're going to look at one or two more examples um, in the next lecture, which is this one. So what I'm going to do is that I'm going to go through quickly what we did last time, and then we can continue or rather proceed from there. So let's see how it goes. So we have in physics, like I said. Now we started looking at addition and subtraction of vectors. Okay. Addition and subtraction of what? Vectors. Now, we said that when we're looking at addition and subtraction of vectors, we're going to look at it in two ways. That is, number one, we look at in terms of unit vectors, okay? In terms of unit vectors. So we can add or subtract vectors when they are given in form of what? Of unit vectors, right? So in this case, it means that, let's say, given that, right? Given that A, the vector A is equal to AXI plus AYJ plus AZK, right? And another vector B is equal to BXI plus BYJ plus BZK. Okay. Find A, we can say A plus B, and then B, we can say A minus B. Okay. A plus B, and we also find A minus B. So when we have M plus B, okay, A plus B is simply going to be equal to the vector A, which is AX I plus AYJ plus AZK, and then plus what? Bx I plus by j plus bz k. Okay, like that. Then what we simply do is that we collect the like terms. In other words, we get those in the x components together, the y components together, and the z components together. So by doing that, what we're going to end up with is axi plus bxi, right? And then plus ayj plus byj, then plus azk plus bzk. Now here you can see that the I and the I is common there, the j is common, the k is common. So we're going to factorize, so we're going to have ax plus bx I plus ay plus by j, then finally az plus bz, okay, k. So if we had values, if we had numbers, we would get the exact value there, right? We would get the exact value. So that is how you add or subtract vectors that are in components form, in form of components, all right? So let's go ahead and look at part B, where we're subtracting now. So if there's any question, please take note of the question, and then what we're going to do is that when I pause the video, when I end the video rather, then we can ask the question so that they can be able to clarify. Otherwise, if I start explaining, rather attending to questions, then we're going to find that the video is going to be too long and it's going to be a bit hard. I don't have the that technology that I can use to do all those. Okay, so let's look at part B. So part B says A minus B. So this is going to be equal to AXI plus AYJ plus AZK, right? Then minus BXI plus BYJ plus BZK. Okay. So now here we have a negative. So this negative we are going to distribute it throughout in the vector B. So this is going to be AXI plus BYJ, AYJ, then plus AZK minus BXI minus, because remember negative by positive is negative, BYJ, then negative by positive is negative again, this is BZ minus BZK. Okay, then as usual we get the components together. The X component we're going to have AXI minus, because it's coming with a negative, minus BXI, right? Then we have this one plus AYJ minus BYJ, right? Then plus AZK minus BZK. Okay. Then this is going to give us what? We're going to have, if we factorize here, we can put them in brackets like that. So we can factorize here, we're going to have, this is AX minus BX I, and then it's positive, so we're going to have AY minus BY J plus, because it's positive there, AZ minus BZ K. Okay, so that is the answer that we are going to have if we get the subtraction, if we do subtraction there. Let me just get my calculator quickly. Right. Okay. So let's proceed. Let me give an example. Let me give an example. Say example 1. Given that A is equal to 2I minus J plus 4K, and B is equal to let's say 3I plus 2J minus 7K. Okay, find the magnitude of C given that, okay, so let's say this is A. Find the magnitude of C given that C is equal to A plus B. Okay. Then B, let's say of the magnitude of D. Okay. that D is equal to B minus A. All right. So solution, right? So I said that we find the magnitude of C given that C is equal to A plus B. So in other words, we first need to find C, which is equal to A plus B. Now our A is what? Is 2I minus J, then plus 4K, plus our B is 3I plus 2J, then minus 7K. Right. So let's find that. So 2I plus 3I, that is 5I, right? And then negative j plus 2j, that is going to give us j, okay? And then we have 4k plus negative 7k, that is going to give us negative, negative what? Negative 3k, right? Negative 3k, because remember this is going to be 4k minus 7k, okay? So it is negative 3k. So now we can see that the vector C is what? Is 5I plus j minus 3k, okay? Then we go ahead and find the magnitude of that, right? Let's find the magnitude of that. I'm going to do it from this side. So therefore, the magnitude of C is going to be equal to the root of 5 squared plus 1 squared, then plus negative 3 squared, which is going to be equal to 25 plus 1 plus 9, right? Which is going to be root of what? Root of 35. Okay? So root of 35 is going to be what? Root of 35 is equal to 5.9. So this is 5.9 units. Okay? 5.9 units, right? So you guys are going to deal with the other one. So what you simply do is you subtract, you get B, which is this, you subtract the first vector, which is that, and then after you get the difference, you calculate what? The magnitude, right? So what you're going to do after you do that, you can send the solutions to me, and then I'm going to look through them. Okay. So basically, that's what you do. You just subtract A from B, and then the answer that you're going to get, you do what? You find the magnitude. It's very, very simple, not something that you should even struggle about. Okay, so let's go to the next part of our addition and subtraction, where we look at components, right? Where we add, or rather we find the resultant, right? We find the resultant of two or more forces using their components. Now remember, so we say this is 2 in form of components, okay? Now remember what we said is that if we have a vector like this, if this is the vector A, right, then we have 2 components, and then it's at the direction theta. We can say that we have the x component, which is ax, equal to A cos what? Cos theta, and then ay is equal to A sine theta, right? That's what we should remember. So this is very, very important, and this is, of course, our vector A. Okay, such that we write our vector A in the form is going to be in form of unit vectors, right? In form of unit vectors, this is ax I plus ay j, right? Like that. So you can see that there's a connection between the component form and the unit vector form of writing these vectors. Okay, so let's go ahead and look at an example. So let's say 4 vectors, let's say example 1, example 2, 4 vectors, 4 forces, 4 forces, F1 equal to 70 newtons at 30 degrees. Then we also have, let's say, 40 newtons at, let's say, negative 45 degrees, right? Then we also have, let's say, 65 newtons at 115 degrees. And we also have another force, let's say 85 newtons at, let's say, 20 degrees below the negative x-axis. Okay, find these forces act on a point. Find their resultant. Find their resultant. Okay. Now the other way they can also say this in questions, they can also say find their equilibrium. In other words, when you say equilibrium of two or more forces, is one force that can cancel out all the other forces, right? That can balance all the other forces. That is what is called the equilibrium. Okay. So now let's look at the question that you're given. We're saying that these four forces. So the first thing, when you're given a question like this, you need to imagine and form a diagram. It's not always that you're going to be given a diagram. So the first thing that you want to do is to form a diagram on your own. Okay. So what we have is this. If this is our xy plane, right? That is our xy plane. The first vector, as we can see, it's 70 newtons at 30 degrees. Okay, so 30 degrees should be somewhere here, and then that is 70 newtons. Okay, at what? 30 degrees. Right. And then we also have 40 newtons at negative 45 degrees. Now, when we say negative, remember angles, conventionally, angles are measured from the positive x-axis, okay, going in the anti-clockwise direction. Now, if we go the other direction, that is in the clockwise direction from the positive x-axis, going in the clockwise direction, then the angle is going to be what? Negative, right? So in other words, when we say negative 45 degrees, we're simply talking about an angle measured from the positive x-axis going in the anti-clockwise direction. So it's going to be somewhere here. And that is 40 newtons. So 40 newtons at 45 degrees, negative 45 degrees. Okay? Or 45 degrees below the positive x-axis. It's one and the same. Then we also have 65 newtons at 110, right? So 65 newtons is going to be somewhere here. Let me just draw that properly. Okay, so 65 newtons somewhere here at 110 degrees. So this is 115 degrees. Okay. Then from there, what we have, we have what? We have 85 newtons at 20 degrees below the negative x-axis. So the negative x-axis is here, and then we measure 20 degrees below that. So it's going to be somewhere there, right? So this is now 85 newtons at 20 degrees, like that. Okay. Now remember what I was telling you the other time. So when you look at this vector, the first vector, the first force, it means that the x component is going to be positive, and the y component is also going to be what? Positive. Okay. Is that okay? So the first, it means that the x component is going to be positive, the y component is also going to be what? To be positive, right? And then if we look at the second vector, this one, or rather the second force, because we can see that it's going towards the positive y-axis and the negative x-axis, it means that the x component is going to be negative and the y component is going to be what? Positive. Okay, that's what you should keep in mind. Make sure you keep that in mind. Then when you look at the 85 newtons force, we can see that it's going in the negative x-axis and the negative y-axis, meaning that it's going to be negative x, comma negative y. Both components should be what? Should be negative. Then lastly, if we look at the 40 newtons force at 45 degrees below the positive x-axis, we can see that it's going towards the positive x-axis, so the x component is going to be positive, while the y component is going to be what? Negative. Okay, so before you even start working out, you should be able to analyze that so that you're not going to even confuse yourself at all. Okay, so let's start working out now and see what we're going to have. So I'm going to draw a table, right? We're going to draw a table. So we have force here, and then x component, and last we have the y component. Okay. So the first force that we have, like we can see on the diagram, is 70 newtons at what? At 30 degrees, right? So what are we going to have? Remember, the x component of that is going to be what? Is obviously going to be 70 cos 30, right? 70 cos 30, which is going to give us what? Let me just punch in that. So 70 cos 30, that's 60.62, 60.62 newtons, right? And then on the other hand, in the y component is going to be 70 sine 30, which is obviously going to be what? 35.00 newtons. Okay. Then we go to the second force, which is 65 newtons at 115 degrees. Okay. At 115 degrees. So you can see that we've seen from what we've analyzed that the x component should come out negative, right? So let's punch into the calculator. So this is going to be 65 cos 115, right? 65 cos 115. Let's see if it's going to come out negative. 65 cos 115, that is negative 27.47. Negative 27.47. So you can see that what we desire it to be is what it has come out. Because, and why is it coming out like that? Is because the angle is what? Is greater than 90 degrees. So we expect that cos is only sign here that is positive. The rest are negative. Tan is negative and cos is negative. So that's why you can see that cos is coming out negative there in the second quadrant. Okay. Then we go for sine, right? We go for the y component. It's going to be 65 sine 115, which is going to be. So you can see from there it's going to be 65 sine 115, right? 65 sine 115, that is 58.91. Okay, so you can see that it has come out positive, and that is how we want it to be. Okay, so you have to be mindful of the signs. Please be mindful of the signs. That's what is really going to kill you if you're not careful. Okay, in an exam, that is going to take away your marks. Be mindful of the signs. So you can see it's come negative here and it's come out positive, just like we anticipated it to be. Then let's look at the third, which is 85 newtons at what? At 20 degrees below the negative x-axis, right? Below the negative x-axis. So this is going to be what? This is now, because the angle that we have is an acute angle, and we can see that the signs should come out negative, so we should include the negative in our working. Okay, so because here we're going to have 85 cos 20, but if we write it just like that, if we get it just like that, it is going to come out positive, right? if we work it out the way it is like this, the way we've written it, it's going to be positive, and yet we want it to be negative, right? So what we do, we are going to put a negative outside the brackets so that we can account for the negative sign. So this is now going to be 85 cos 20. 85 cos 20, this is going to be 79.87, but there's a negative, so this is going to be negative 79.87. Okay, then this side is going to be, obviously as well, we need it to be negative, okay, but the fact that the angle we are using is less than 90, it means that it's going to be positive, so we have to include the negative outside. Okay, so this is going to be negative 85 sine 20, which is going to be equal to what? 85 sine 20, that is going to be negative 29.07. Okay, then lastly we got to which one? We got to 40 newtons at negative 45 degrees. Okay, 40 newtons at negative 45 degrees. So here we're just going to put the negative angle directly into our calculator. So this is going to be what? The x component is going to be 40 newtons cos negative 45. Okay. So in mathematics, we're going to understand better when we look at negative angles in trigonometry. So 40 cos negative 45, that is giving us what? 28.28. Okay, 28.28 is positive, just like we anticipated, right? Just like we anticipated. Then let's go to the positive, to the y component. This is going to be 40 sine negative 45, right? 40 sine 45 is going to give us, so this is 40 sine negative 45. This is going to give us what? Negative 28.28. Okay, just like we anticipated, we can see that it's coming out negative as well. Then we close because we are done with all the forces, right? So now we need to find the sum. Okay, the x component of the resultant force is going to be equal to the sum of all the forces in the x-axis, which is going to be equal to what? So we now need to add all these in the x component, which is 60.62, then minus, because it's negative, minus 27.47, then minus, because it's also negative, 78.87, then plus 28.28. Right. So this is giving us negative 17.44. Okay, newtons, of course. Then the y component of the resultant force is equal to the sum of the forces in the y-axis, which is equal to, this is going to be equal to what? We add all these forces. This is 35.00 plus 58.91, then minus 29, because it's negative, minus 29.07, and then minus 28.28. So this is now what? 36.56. Okay. So you can see from here, look at the signs, look at the nature of the components that we have obtained, right? If you look at this, you can see that it's negative, right? It's negative. It's like we have negative x, comma, positive y. Okay, negative x, comma, positive y. So we anticipate it to be in which quadrant? In the second quadrant, right? Because that's why we have negative x, comma, y. So we expect our resultant force to be somewhere here. If we were to plot these values, if we were to plot them, we would find that it's going to be somewhere here, right? Probably it's going to be somewhere here. This is going to be the resultant. Okay, that's what it's going to be. So let's go ahead and find the magnitude and the direction of this vector, of the resultant vector. So now to find the magnitude and direction, of course, we know that in this case, the resultant force is going to be equal to the magnitude of the resultant is going to be Rx squared plus what? Ry squared, where Rx is the x component of the resultant force and Ry is the y component of the resultant force. Okay, so I should be finishing soon. This is then going to be equal to the root of negative 17.44 plus 36.56 squared, of course. Okay, squared. So that squared plus the 17.44 squared. So this is then going to give us the root of this is going to be root of 1640.7872. So if we find the square root of that, we're going to get 40.5. Okay, 40.5 newtons. Okay, so that is the magnitude of our resultant force. Okay, that is the magnitude. Now we need to find the direction. Okay, we need to find the direction. What do we do? So how do we find the direction? Let me erase on top here. So remember I said that direction, theta is equal to what? Tan inverse, right, of, in this case, Ry over Rx, okay, which is going to be equal to what? Tan inverse of what? Our Ry is 36.56 divided by negative 17.44, okay. So what do we have? So that is 36.56 divided negative 17.44. And then we apply tan inverse. Okay. So this is giving us, so we're going to say that alpha, we get alpha, we say that alpha is going to be equal to, this is like, okay, this is going to be negative 64 point what? 0.5 degrees, right? Now, that angle, right? Or we can remove the negative. It means that what we have is this, right? What we have is this. Okay. What we have is something like this. It's coming out somewhere here. So it's like this is the 64.5 degrees. Now the angle that we are looking for really is this one, right? So what we do, we are going to, because it came out negative, remember it was negative 64.5. So we're just going to add the 180, because remember, if this is negative, so if we add this angle and that angle, if this is our theta, right? So if we add this and that, it should give us what? It should give us 180. So we're going to subtract that. We're simply going to subtract this angle from 180. So theta is going to be equal to 180 minus what? 64.5. Okay. So it is going to be 115.5 degrees. Okay. So that is going to be that's going to be our direction. Okay, that's going to be our direction. 115.5 degrees. So what I'm going to do is I'm going to end this video here, and then if you guys have questions, you can ask so that I clarify or respond to your questions.